Welcome back everyone, Patrick here. Moving on to the next example. This is going to be a pretty cool one. I actually think I'm going to make a couple of videos with these kinds of examples just because they're super unique and different. So what we have to do is we have to find an expression for the number of shaded regions in the nth diagram. Okay, so the nth diagram meaning this is the first diagram, this is the second, this is the third, this is the fourth. Now, with these, notice that there's a combination of both shaded regions and unshaded and empty regions. So with this kind of question, what I recommend doing is actually first making a table of values before creating the expression. So what I'm going to do is create some columns here. And even though we are finding the number of shaded regions, I'm going to create a column for the total number of regions, and then I'm going to create a column for the unshaded number of regions, and then finally a column for the shaded regions. And actually, if you think about it, the way that these three here relate, you could take the total number of regions, which in this case, in this second diagram, it's going to be 4, and subtract the number of unshaded regions, which in the same diagram, it's going to be 1, to get the number of shaded regions, which is going to be 3. So the way these three relate here is total minus unshaded is equal to shaded. So what we're going to do here is let's go through these one by one. So let's start with this first diagram. Okay, so this diagram here, this diagram number, this is like our n value. Okay, so this is going to be our n value, and then let's call this column here our s value. So we're going to have to make an expression for s, the number of shaded regions, in terms of the diagram number. So starting with diagram 1, how many total regions are there? Well, there's 1 total region. How many unshaded regions are there? There's 0, meaning that there is 1 shaded region here, right? It's just the 1 shaded region that's filled in. So in the second diagram, let's actually put the, you know what? I'll just keep it like this for now. So with the second diagram, how many total regions are there? There's 4. How many unshaded regions are there? There's 1. And so how many shaded regions are there? There is 3, like that. Then in the third diagram, we got what? 1, 2, 3, 1, 2, 3. So 3 times 3, which would give us 9 total regions. Notice there's 2 unshaded regions, and then 9 minus 2 would give us 7, like that. And then finally, the fourth diagram, how many total regions are there? 1, 2, 3, 4, 1, 2, 3, 4. So 4 times 4, it would give us 16 total unshaded regions, 1, 2, and 3. And then 16 minus 3 would give us 13, like that. So the reason why I recommend making columns like this, including the total and the unshaded. First off, sometimes they may even ask you to create an expression for the unshaded regions as well. So that's one reason why it's good to make this other column too. But the real reason is because notice that it's actually easier to see a pattern with these 2 columns versus just this one. Let's say we didn't add these 2 columns here and we just had this shaded column. Notice it's kind of tough to see a pattern of how the diagram number relates to this because we got 1 and then we have 3. Notice there's a difference of 2 here, but then we have 3 to 7 and then there's a difference of 4, and then from 7 to 13 then there's a difference of 6. If you really start analyzing it and looking at it, you could start coming up with a pattern. But notice here the pattern is a lot more apparent in this column and in this column. So let's say we're dealing with an nth diagram. So this could be 5, 6, whatever. What's the total number of regions going to be? Well, notice, how are we getting from 1 to 1, 2 to 4, 3 to 9, 4 to 16? Well, we're just squaring this number, right? 1 to the power 2 gives us 1, 2 to the power 2 gives us 4, 3 to the power 2 gives us 9, 4 to the power 2 gives us 16. And so for the nth diagram, the total number of shaded, not shaded regions, the total number of regions is going to be n squared, like that. Right? So the fifth diagram, the total number of regions is going to be 25, 5 to the power 2. All right? There's going to be 5 on this side and then 5 on this side. So in total, there's going to be 25. Now, notice here for the unshaded column, it's just simply going up by ones. Right? So it starts at 0, then there's 1 unshaded region, then 2, and then 3. So this pattern, it's pretty obvious what's happening. But how do these numbers relate to this? Because remember, this is all going to be in terms of the nth diagram, right? This is going to be the independent variable. So it's got to be in terms of this variable. So how does this 0 here relate to this 1? How does this 1 relate to this 2? Well, notice we're just taking this value and subtracting 1 each time to get this. So 1 minus 1 would give us 0. 2 minus 1 would give us 1. 3 minus 1 would give us 2. 4 minus 1 would give us 3. And so for the nth diagram, what we would have here is n minus 1. So again, if we're dealing with a fifth diagram, 5 minus 1, there's going to be 4 unshaded regions. There's going to be 25 total, and then 4 unshaded. And then, how are we getting these values? Well, now instead of directly trying to figure out a pattern over here, we know that this column, as we stated earlier, is just this column minus this column. And so notice that it's just going to be, for the nth diagram, it's just going to be n squared minus this value, which is n minus 1. You just got to be careful. You got to put that in brackets because you're subtracting that whole thing right there. Right? So going back, the fifth diagram, it's going to be 5 to the power 2. So let's actually draw the fifth diagram. Right? Now that we know the pattern, so we'll have 1, 2, 3, 4, and 5. And then we'll have 1, 2, 3, 4, and 5, like that. So there's going to be 25 total squares. And then the number of unshaded squares is going to be, we're on the fifth diagram, is going to be 5 minus 1. So it's going to be 4. And notice that it has sort of like a pattern here in the diagram. To be honest, I don't think it actually matters where you put it, but just to keep the pattern consistent, notice what's happening is the unshaded squares is going to be this, 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 and this, right? The diagonal of 4 over here. And then what's going to happen is the rest is going to be filled in like that. Right? And then amount that's going to be filled in is going to be 25, the total, right? The total is 25 minus this 4 over here, that's unshaded, to give us the number of shaded regions to be 21, right? 25 minus 4 would give us 21. Notice if we plug in 5 over here, 5 to the power 2, 25 minus 5 minus 1, we do this bracket first, which is 4. 25 minus 4 would give us 21. So that's actually how the fifth diagram is going to look. And then you can figure out how's the 10th diagram going to look, or the 50th diagram. They may actually ask you that. How many shaded regions are there going to be in the 50th diagram? Or how many unshaded regions are there going to be in the 50th diagram? So in this case, they're only asking for the shaded regions. They're only asking for this expression over here, but it may be a more complex question where they're asking for this expression too, for the number of unshaded. Even for the total, they may ask as well. That's why I recommend, even if they're just asking for this, create these 3 columns, because a lot of times it's easier to get the pattern from these 2, and then whether the operation is subtracting or adding, you'll have to see the actual example you're working with. You're going to have to kind of figure out, do a little investigating to see the pattern. But a lot of times these two columns are easier to get than this one. Now, notice here, this isn't simplified, this expression, right? We could distribute the negatives. So the final expression, S, which we're letting be the number of shaded regions, is going to be n squared, and then when we distribute that negative inside the bracket, we'll have minus n plus 1, like that. And so that right there ends up being the answer. That's the expression for the number of shaded regions in the nth diagram. And then again, you can kind of intuitively check it. So let's say we're dealing with the 7th diagram. Well, we know the total is going to be 7 to the power 2, 49. And then the unshaded amount is going to be 7 minus 1, which would be 6. So the number of shaded would be 49 minus 6, which would be 43. Okay, and then what we can do is we could take that 7 for this. Remember, n is 7, the 7th diagram. That's what we're working with here. You could plug it in here and see if you get this amount. So 7 to the power 2, 49, minus 7 would give us 42, plus 1 does indeed give us 43. So you can try a couple of extra diagrams to check this if you get the time on a test. But again, personally, this is the process that I go through for this kind of question in order to get that expression.